Section 614, solving systems of three equations with three unknowns. So we're going to be doing a handful of algebra on this little section to get through all three of those equations and those three variables. So we're going to come up with some algebra strategies on solving these three equations with three variables. We're going to think of maybe a different way if we need to, because not all of them will work the same. And I don't think we'll have time to get to it today, but I'm looking into tomorrow when it comes to the graph of these three-dimensional systems, of being able to graph them. And the only problem with graphing these three-dimensional, if relying on graphing these three-dimensional equations is like your graphing calculator doesn't really graph in 3 dimensions. Desmos doesn't graph in 3 dimensions. So the only thing you have is that CPM 3D plotter. And we know once you kind of get out of this class or get out of high school in a sense, you're not going to have that CPM 3D plotter. So I get looking at it 3-dimensionally to figure out where this all intersects in that solution. But we're really going to probably focus more on those algebra strategies than anything else. Just so that's what's going to help you, in the future and all that good jazz. Sound good? All right. So what are the solutions in 3 dimensions? So in chapter 5, I believe it was, we went through, and even before, I know first semester, we went through these systems of equations and started just kind of playing around with solving these systems. And usually we only had 2 variables on these equations to figure out how to solve these systems. So by definition of a system is just 2 or more equations. So on this one we have 2 equations. And a system is where those equations, they're working together in that same kind of problem or in that same dimension, and you're looking for that solution. So like for these, we know that our highest degree is 1, so we know both of these are going to, if we were to graph them, we would get a line. So and we're going to get 2 lines. So you're going to get one line that goes like this, you get another line that goes like this, and then that solution to that system is where what's that thing called? Starts with an I. Where they intersect, right? And we know that these 2 lines intersect at a point. So you're finding that X and Y coordinate, or that point where it gets solved. Just jumping ahead, but we're going to come back and do this problem. When it comes to solving them in 3 dimensions, again, we have a system. System is just 2 or more equations. We technically have 3 equations. And we learned that when it comes to graphing these, when you graph them with that Z, that 3rd dimension in there, it kind of gives it that 3D effect, or it kind of like comes out of the screen at you. So hard to kind of like graph, but ultimately you have just 3 lines. And these 3 lines, if you're looking for the solution, use your imagination and act like we're, drawing in 3-dimensional. You might have a line that goes like this, another line that goes like this, and then you got another line. Whoops, that's a really bad one, right? Another line that kind of comes through here. And think of these are all like in a sphere, however, they're all going in that 3 dimension. Same principle still applies. When you're looking for that solution to that system, that solution, we'll just make our point a little bit bigger, that is where all 3 of those lines intersect. And all 3 of those lines are going to intersect at an X, Y, Z coordinate because we're in that 3rd dimension. So we have that space, in front of us or behind us, however you want to think about it, right? So same principles apply. It's just a little bit more algebra just to get there. You guys excited to try these? I know you are. Like I can just feel it. I can feel it, right? All right. So when it comes to a little bit of review of when it comes to solving these in 2 dimensions, or 2 variables, that X and Y variable, there were 2 different ways that we would go through. I'm going to change this color real quick. That we could sit there and try and find the solutions. The one is you can use substitution. Right? You're going to solve for one of the variables and then you're going to plug that in on the other one. And the second form we use is elimination. So we're going to kind of do some algebra to get rid of one of the variables So then we can solve the other variable and then kind of like plug it back in. So it's a personal choice on which one you want to do. Sometimes, and the more you do these, the more you kind of see, you kind of like, you know what, I think on this one I'm going to use substitution, on this one I'm going to use elimination, right? So when I look at these two and I look at my system that they give me, if I want to use substitution, I either need to solve it for this x or this x, or I got to solve it for this y or this y. And I kind of look at them and I'm like, well, if I go to solve it for x, like to get rid of that 30, I'd have to divide by 30. And this guy doesn't like to be divided by 30. So now I'm going to deal with fractions. So I'm like, maybe I don't want to solve that one for x. And I kind of think the same thing up here. I'm like, I don't want to solve that thing for x either. So you're kind of going through, maybe solving it for y wouldn't be such a hard deal because you're dividing by 2 and you could divide everything by 2. So that's one way you can do it. When it comes to elimination, this is where you're looking to try and match up that x and y with those opposite signs, so that way when you add these two equations together, it eliminates or it completely gets rid of one of the variables. So when I look at this system of equation, I see it right away. Do you see what happens with those y's? Those y's they have the same coefficient, they're just opposite signs. So I know that I can eliminate those really easy. I don't have to do any extra work to eliminate those, right? I don't have to go through solving an equation, or I don't have to go through and multiplying by something to get these two exactly the same. They're already the same, just those opposite signs. So I'm going to start with elimination. So I'm just going to rewrite the problem. So we got what? 12x minus 2y equals 16. And 30x plus 2y equals 68. Right? So I'm going to work by adding these two equations together. So when I add my x's, I end up with 42 x's. When I add my y's together, they go away. And that's going to equal what? 80. I think I heard somebody say 84. You gotta speak up sometimes so I can hear it. And then to get x all by itself, to solve it, what am I going to do? I'm going to divide by 42 and I'm going to get x equals 2. Right? And when I look back in my problem, how many variables do I have? I have 2. I have an x and I have a y. So I solved it for x. So now I just got to solve it for y. Pick whichever equation you want. You can either pick the first one or the second one to plug that x in for. Anybody got a preference? First one? I'll do the first one, yep. So 12 times my x is now 2 minus 2y equals 16. So 24 minus 2y equals 16. Okay. Subtract 24 from both sides. So negative 2y is going to equal, what you got? Ooh, there we go. 8, negative 8, right? Divide by negative 2 and y is going to equal 4. So usually, a lot of times they want you guys to write your solutions like in that point form. So that ordered pair, because there's 2, triple pair if there was 3. So x and y, alphabetical. So 2, 4. So these systems of equations, when you graph these two lines, they intersect at that point 2, 4. Sound good? All right. So we're going to use kind of that same principle when it comes to solving these in 3 dimensions or with 3 variables. There's an extra little step on this. Okay. So I'll give you guys a minute to be able to write down this little system, right? And it's a system because it's 2 or more equations. And this one is in 3 variables.
I still get confused. I forget about spinning the dial.
All right. So now what we have to do is we can't solve it with the 3 variables. So we want to be able to work on our equations, and we got to get it down to 2 variables. And once we get it down to 2 variables, we're going to do elimination again, and then we can work backwards. So you got to find 2 equations to start with, and then we're going to get another 2 equations. So we have to first ask ourselves, do we want to eliminate the x's, the y's, or the z's? We have to be able to eliminate one of those to begin with. And it's really a personal preference which one you want to pick. Sometimes I try to find the variable that has those opposite signs. Sometimes I think it might be, it's a little, I don't have to worry about multiplying through by a negative and possibly missing one of them. So I'm going to go with eliminating y to begin with. Okay? So we pick the variable that we want to eliminate first. So then now in order to eliminate it, we need 2 equations. So you can pick any 2 equations to start with, because you're going to have to pick another 2 here in a minute. So I'm going to label these just for conversation purposes. I'm going to say this is like equation A, this is equation B, and this one's equation C, right? So I'm going to start off with A and B, and I'm going to put these 2 together, and when I add them, guess what's going to happen to my y's? They're going to get eliminated, right? So I'm going to start off with those first 2. So I'm going to start off with 2x plus 3y plus 3z equals 6. And b, which was 6x minus 3y plus 4z equals 12. Right? And I'm getting rid of my y's. And when I look at it, I don't even have to multiply anything because my y's are already the same coefficient with those opposite signs. So I'm going to add these 2 together. And what do I get? I get 8x. My y's go away. Plus 7z equals 18. Right? So now I'm down to 2 variables. I'm down to my x and z variable. You guys following along? All right. So now I need to find another 2 equations. I can't use A and B. I have to use 2 other ones. And I'm going to do the same thing, and I'm going to get rid of y. So I can either use B and C, right? And I can get rid of my y. Or I can use A and C. Okay? It's a personal choice on which one you want to pick. Again, though, I'm going to go for A and C because my signs are already opposite of each other, and then I don't have to do that extra math, right? So for A, I'm just going to write it over here. So I have 2x plus 3y plus 3z equals 6. And then C was 2x minus 3y plus 2z equals 6. I'm eliminating y. Works out perfect. So I'm going to add these guys together, and I'm going to get 4x plus 5z equals 12. Everybody good so far? All right. So now I have these 2 new equations. Right? Sorry, guys. I get this equation, and I get this equation. So now I'm going to put these 2 guys together, and then I'm right back to where I was just a second ago, right? So if I have 8x plus 7z equals 18. And then now I have 4x plus 5z equals 12. That's a 7 if you can't tell, because I can barely tell it's a 7. Right? So now we have two variables. Now we got to eliminate one of those variables. So now you're asking yourself that question again. Do I want to try and solve it for one of those variables and plugging it back into the other one? Or do I want to just keep going with elimination? I'm going to go with elimination, right? So I have to make a choice. I have to choose, do I want to get rid of my x's? Am I going to eliminate x? Or am I going to eliminate z? So I need to get my coefficients, the number out front, to be like the same number with opposite signs. So if I'm looking at my z's, like really between like 7 and 5, I'm going to try and get that to 35. But that means I got to multiply the top by 5 and the bottom by z. Or I can look at my x's and be like, if I get this guy to be a -8, it's going to eliminate, right? So I'm going to multiply everything by -2, right? Top and bottom. So I'm just going to rewrite that top equation. 8x plus 7z equals 18. And then when I multiply the bottom by -2, I got to make sure I multiply everything by -2. So -8 minus 10z equals -24. Okay. You guys all good with that? So now when I add these guys together, my x's are eliminated. And I have -3z equals -6. Okay. Divide by -3, z equals 2. So I solved it for one variable, but I still need to find that triple pair, or that triple order. So I have my z, so I just got to go backwards to solve it for y and solve it for x. So these two equations, or we can even look at it right here, these two, we're down to x's and z's. So we know that our z is 2, so just pick one of those to plug it in for z equals 2. I just got a little bit more room under this one, so I'm just going to pick this one, but you can pick whichever one you want, right? So if I work backwards, I know my z is 2, so 4x plus 5 times 2 equals 12. 4x plus 10 equals 12. Subtract 10 from both sides. 4x equals 2, and x equals 1/2. We can have fractions. Fractions are our friends, right? So now you have x and you have z, so you still need to find y. So the only place that we have y, because we've eliminated y, is if we go back to our original 3. So it doesn't matter, whichever one you like, A, B, or C, we can pick those ones. So just for the fun of it, I'm going to pick A. Right. I'm running out of room. Sorry, we're going to put it over here. I apologize. Right. So 2x plus 3y plus 3z equals 6. So 2 times 1/2 plus 3 times, we don't know what our y is, plus 3 times 2 equals 6. Sorry guys, running out of room. 2 times 1/2, that's going to get us to 1, plus 3y plus 6 equals 6. So what do I got? 3y plus 7 equals 6. Subtract 7 from both sides. 3y equals -1. Divide by 3. Y equals -1/3. Right? So now I have all three of my variables. So last but not least, I just have to write it as that that triple pair, that ordered triple. So we just got to put it in order of x, y, z. Right? So my x is 1/2, my y is -1/3, and my z is 2. And that there is our final answer. Lots of algebra on these, huh? Let me pull you guys up. Yeah. I think I gotta stop sharing it. So we're not gonna do, well, we can. I got one more to kind of show you or just to talk to you about, all right? Awesome, good job. So if we remember, so when it comes to these 3 lines, granted they're all in 3 dimensions, but those 3 lines are intersecting each other. All 3 of those lines are intersecting each other at that point that we found, right? That's how we know it's a system, because all 3 of them are intersecting at that point. So sometimes though, if they might give you a problem and they want you to solve this system, and if I look at these first 2 equations, these 2, what do you remember about those 2 equations? What do you think those 2 lines are to each other?
They have the same letters touch.
Yep. So those coefficients in front of those x, y, and z, they all match up, right? So these 2 lines are, starts with the P. They're parallel, right? So these 2 lines are never ever going to intersect because they're parallel. So can't quite draw in 3 dimension, but right? So you got this line and this one is parallel. And that third one's going to intersect somewhere. But do they intersect at one point? Not all of them intersect at that one point because of those 2 being parallel. So guess what this one's called? Starts with an N. No solution. Because in order for there to be a solution, all 3 of them have to intersect at the same point.